Right, so moving one step on from what we did yesterday. Yesterday we looked at just straightforward using the table from right to left. Today what we're going to get are problems that cannot use the table. So there are these things called identities. So the reason that I gave you a formula sheet yesterday, and yes, you can have one in a minute if you haven't got one, is because on the back of the formula sheet, so I've shrunk this, it will be a big version, there are a whole lot of things. Huge amounts of formulas, including ones that we might be using as far as measurement is concerned, but there's also all these groups of what looks like trig. Now, these formulas are a part of one of the other standards. So in one of the standards, the trig standard, which we're going to do, there is a whole part of it that is using these formulas that we're not going to do. But the one thing we are going to have to do is understand these formulas as far as rewriting a trig statement. And the reason for that is we are not allowed to integrate a product. So we have to change something from being a product into being a sum. That means we can't be timesing things with x's together. We need to rewrite things so that they are adding or subtracting. All right? So, especially in trig, this is going to be useful. So we might get now there is one there that says products and sums. That's really good. Yes, they're very handy as well. But there are all sorts of other things. Identities just mean that there is something happening. So we've got the cosine rule. We learned that last year. Identities under that are that cos squared plus sine squared equals 1. That one has been a rule that was taught in year 11. Now, you don't even get to know it if we don't do a particular standard. But down the bottom, there is one that says double angles. We're interested in that one. And we're interested in the products one up the top. They're the two that we're interested in using to rewrite statements. So what am I talking about? Let's have a look at this example. So if we've got this, all right? That says sine 5x times sine 5x, all right? In our table, there is no sine on the right-hand side, sine squared on the right-hand side, so we can't use the table, no sine squared, all right? We can't do a sine x times a sine x. We have to rewrite it. So we look on this table for something that will change it to something that doesn't have a squared and doesn't have two things multiplied together. So we are specifically looking this time at the double angle formulas. And you will see that under cosine of 2a, cosine of 2a is not a product. There is one with a 2 sine squared a. We are specifically going to that 2 sine squared a there to use it. So the formula we are looking at here from the formula sheet is the one that says cosine of 2a equals 1 minus 2 sine squared a. All right, that is going to help us get rid of the squared. So what we are going to do is we're going to rewrite this. So it's in there, and we're going to rewrite it. So we've got cosine of 2 times 5x equals 1 minus 2 sine squared of 5x. We want sine, this bit here, over here. So we want to have 1 minus 2 sine squared 5x equals cosine of 2, 5x. Take the 1 away, minus 2 sine squared of 5x equals cosine of 2 times 5x, which we could write as 10. We all know it's 10. Then we're going to get rid of this one by dividing. So sine squared of 5x equals a half negative cosine of, and I'm going to change that to 10x because I can, and I've got to divide this one also, so plus a half. -1 divided by -2. All right? So I now have here what I've got here. And here I have a sum, right, a plus sign, but I don't have any trig multiplied by trig. So what I'm going to do is I'm going to integrate this. So I'm going to integrate -1/2 cosine of 10x plus 1/2 dx. All right, so now I can look this one up in my table. It says that negative cosine goes to, or cosine goes to sine, right? So we've got cosine goes to sine, -1/2 is a multiplier, cosine goes to sine of 10x, compensate, 1/10, plus 1/2 goes to 1/2 x, we introduce the x, plus c. Don't need to tidy it up, happy with that. So I've integrated the cosine, I've compensated for the 10th, this is a multiplier, this one here is a constant. When we have a constant, we add an x. All right? Example 2. If we have to integrate cosine of 3x sine of 5x dx, there's no product rule in integration. It's differentiation that has the product rule. So I need to change this product into a sum. So the next set of ones, so these are products over here, and we're going to turn it into sums over here. So we just use the formula, which says, in this case, cosine of, 2 cosine of A sine of B equals, sine of A plus B minus sine of A minus B. All right, so the second line of formulas, because I've got cosine, sine. All right, I haven't got 2. That's okay, I can have half the answer. All right, got half the question, I can have half the answer. So, rewriting it, I'm going to get, instead, a half, I put it out here actually, half, that's fine, of sine, A plus B is 8x, minus sine, 3x minus 5x is negative 2x. All right, don't go 5 minus 3, 3 minus 5. All right, plus c. No, dx. I'm going to integrate it. That gives me a half of sine x goes to 1/8, the compensation. Sine goes to negative cosine. So negative cosine of 8x. All right, so 8, compensation is an 8. Sine goes to negative cosine of 8x, okay, minus compensation of negative 2 is negative 1/2. All right, sine goes to negative cosine. So I'm going to cosine, but I'm going to put the negative here or here. Doesn't matter which one you change. But I'm going to change this one, make it a plus. All right, so that plus has come about because sine integrates to negative cosine. Negative 2x doesn't change. Bracket to hold it all together, plus c. All right, so those are the two sets of formulas that you may need to use to rewrite a trig problem so that you can integrate. One of the big things you have to remember, guys, because you've done it in the skills test, is when you are rewriting, you haven't done the differentiation or integration yet. Okay, so